Welcome to today's explainer, where we're going to completely unlock the secrets of Cambridge IGCSE mathematics. Look, I know higher level math can sometimes feel like this massive, abstract wall of numbers. But today, we're taking a totally different approach. We are using what I like to call the time traveler strategy. We're going to look at the final perfect answer, working backward from success so you can literally see your completed exam paper before you even pick up a pen. We'll start with solid 3D objects, move to the mathematical waves that make up our universe, and finally, show you how to command your calculator to absolutely guarantee those top marks. Okay, here's our game plan for today. We're kicking things off with geometry in 3 dimensions, then moving into core trigonometric graphs, stepping it up with transforming trigonometric waves, and wrapping up with absolute calculator mastery. Let's get right into it. Section 1, Geometry in 3 dimensions, navigating lines, planes, and angles. We're starting in the 3D world, focusing on complex objects. So, let's tackle the ultimate 3D geometry challenge. Imagine a rectangular-based pyramid. A lot of students, let's call them the rushers, will just dive into the numbers, panic, and completely miss what the command word is asking. The trick here isn't guessing. It's extracting a flat 2-dimensional triangle hiding right there inside that 3-dimensional space. You're basically hunting for the exact angle between a sloped edge and the flat ground it sits on. To nail this every single time, you need a blueprint. First, find the projection of the line onto the plane. Think of it as the shadow the sloped edge casts directly straight down onto the floor. Next, calculate those horizontal base lengths using basic Pythagoras. Third, grab the vertical height. Boom, you've just built a right-angled triangle. From there, it's just standard trig to find the angle. And hey, before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Moving right along to Section 2, Core Trigonometric Graphs. We're leaving 3D space and zooming into the 2D shapes of sine, cosine, and tangent.
You cannot afford to just memorize facts without analyzing the visuals. Look at the massive difference here. Sine is this beautiful, smooth, continuous wave rolling between 1 and -1 every 360 degrees. But tangent? Tangent is wild. It repeats every 180 degrees and literally shoots off into infinity. It has 0 amplitude, no max, no min, and breaks entirely at these invisible walls called asymptotes at 90 and 270 degrees. You've got to know these shapes by heart.
Now, cosine is sine's very closely related cousin. It's got the same amplitude of 1, same period of 360 degrees. But, and this is a huge but, it starts at its absolute peak of 1 instead of 0. Plus, check out its symmetry. It reflects perfectly around the 360-degree mark. If you visualize this on the exam, you'll never mix them up. Let's lock down our vocabulary, because examiners love testing this. Amplitude isn't from the bottom to the top. Actually, scratch that. It's from the flat center line straight up to the peak. It's your vertical stretch. The period is your horizontal repetition. How far you walk along the x-axis before the whole ride starts over. Section 3, Transforming Trigonometric Waves. This is where we start shifting, stretching, and compressing these basic graphs to match real-world data. Okay, transformations. If you add a number on the outside of the function, the whole wave simply slides straight up or down. But if you mess with the x inside the bracket, it shifts horizontally. Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Now take a really close look at this table. This is where the magic happens. Tweaking the numbers completely changes the physics of the wave. Put a 2 on the outside, boom, the wave is twice as tall. Put a 2 on the inside, you just swished it, forcing the wave to complete twice as many cycles, cutting the period entirely in half to 180 degrees. Once you spot this pattern, it's basically free marks. Bringing it all together gives us this general formula, A times sine of bx. It's literally the DNA of the wave. The A, right at the front, dictates the height. The B sitting next to the X dictates the heartbeat, or the frequency. Just take 360 and divide it by B to find your new period. See? You're decoding it like a pro. Finally, Section 4, Calculator Mastery. It is absolutely crucial that you know how to visualize all this on your graphic display calculator. Understanding the math is awesome, but proving it on your GDC is where you secure the bag. For the Casio users out there, setting up your calculator is a strict process. You select your mode, type the equation, but listen to me very carefully on step 3. If your calculator is not strictly in degree mode, your graph will look like absolute garbage. It'll just be a flat line. As you can see on these setup screens, setting the angle to degrees is step 1. Then, you've got to dial in your viewing window. Xmin at 0, Xmax at 360, that frames your horizontal period perfectly. Set your y-axis between -2 and 2, and you've just built the perfect canvas for your wave. And would you look at that? The payoff. When you hit draw, you get this gorgeous, perfect cosine wave. It drops from 1, bottoms out at -1, and sweeps right back up perfectly within that 360-degree frame. That is immediate, satisfying visual confirmation that your math is totally spot on. Now, for my Texas Instruments crew, we haven't forgotten you. The logic is exactly the same. Hit the mode button, explicitly lock in degree, and then jump over to your window screen to map out those X and Y boundaries just like we did before. Graph it, and bam, the exact same perfect curve. Using your GDC as a visual verification tool guarantees your manual calculations are correct. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. Subscribe right now to Ace the Exams IGCSE and click that bell. Don't let another exam pass you by. So, as we wrap up today's explainer, think about how far we've come. From wrestling with 3D pyramids to literally graphing the DNA of waves. Once you master these transformations, you can model almost anything in the universe. Ocean tides, sound waves, alternating current. The math is everywhere. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.